Okay, so we started with this, and I said that each of these had a meaning. This is the start. I think everybody kind of knows that one. That's the start value. It's like how much you start with. Well, then you need an end, right? Where's the end go? Like at the end, if you have an amount, like after 5 years, I had this much money, then the end value goes there. This is the base. You could have just said base and you would have been right. And it's also the factor that will tell you whether or not this thing's going to grow or decay. Would you please write this underneath it? If b is greater than 1, if b is less than 1, then tell yourself, what does it mean if b is greater than 1 and b is less than 1? And last but not least, this was where usually time goes. It's obviously the x value, and usually that's time. All right. So, Hallie, what does it mean if b is bigger than 1? It's growth. And less than 1 is decay, obviously. Okay, good. All right, so now I'm going to give you a real problem. Y equals 4, parentheses, 1/2 to the x. And I'm going to tell you some stuff, and you got to know what to do with it. All right. First off, I could just say, how much did we start with? Well, that's easy. It was 4. We had started with 4. Maybe it's 4 llamas, and they're going to slowly... Well, wait a minute. Is that going to grow or decay? Decay. Maybe they're older llamas that can't breed anymore, and so they're just going to slowly die off. Sad but true. They don't live forever, of course. And so let's say that they die off over a period of years. Like if I go like this... Let's put a 5 there so you don't get the 4 and the 4 confused. If I put a 5 there, do you get that that means that the llamas are going to be half as many llamas after 5 years because the older or the sicker ones die off? That's what that means. This is the amount of time it takes for it to do that. Okay, so if it's going to go half as big, it took 5 days. So it's time to do that. All right, now let's imagine, this is my llama example, 4 llamas slowly dying off over time, over the course of 5, and let's make that years. It could have been weeks, but that'd be pretty quick to have all your llamas die off. So I did it in years. My question is, if I'm asked you to do an XY chart and actually graph this, could you? And would you know where the horizontal asymptote is? Go ahead and do that. I'm going to recommend picking logical numbers for x. Don't just pick willy-nilly anything. Because like if you stick in 1, you're going to have to do 1/2 to the 1/5 power. Not going to be fun. All right. Then, when you're done with it, write a limit for either the left end or the right end. I'm going to pause for a second. Will you try to complete that? Okay, so Spencer, give me a number you put in for x. 5. Good choice, because now I have 1/2 to the 1, because all of that turns out to be 1. And then that's 1/2, and then you times it by 4, and you get 2, 5 comma 2. All right. Volunteer, what's another point you put in? Yes. 0, good call, because then the whole thing turns into a power of 0. And then anything to the 0 is 1. 1 times 4 is 4. Awesome. One more volunteer. You must have put in something. I know what I would have put in. Yes. I like it. -1. And if you don't know why he did that, it's because you can make this just flip over by putting in a -1. So I put in a -1, and I know it's -1/5, but the negative part of the power, that negative right there, makes this flip over, and it becomes a 2 to the 1/5. I'm going to rewrite this now. Now my problem turns into y equals 4 to the 1/2, but flipped. 2 over 1. I'm just going to call that 2. To the 1/5. I thought that was negative. Yeah, I took it off and I flipped this. Okay, So now it's 2 to the 1/5. Okay, that's a bit of a pain, but on the test, I would have been okay with you leaving the answer like that. Let me explain why. There's going to be a problem on your test where the number would come out so gruesome like that. Nobody in here is going to know 2 to the 1/5 power, the 5th root of 2. Nobody's going to be able to do it. And so you can just leave it like that and just tell me what you would have typed in on the calculator if you had a calculator. See what I mean? So that's good enough for the answer for that one. All right. Now, I understand that's not very satisfying to try to graph, and we won't even try to graph it. We don't need to, because if I go to over 5 and up 2, and over 0 and up 4, I know this is one of this kind of graphs. You know, I should know that that's exponential decay. And then I should know that the asymptote stays here unless it moved up or down, and there was nothing outside, so this stayed here. It was at y equals 0. That's where the horizontal asymptote was. If you didn't put a horizontal asymptote on your graph, you lose. I can't give you the credit for it unless that asymptote's there, so don't forget that, okay? All right, last thing I said is make a limit, and how many of you actually remembered that and actually have a limit? Not many. Okay, let's take a second right now, and let's pick the limit on this end. Do the limit on the left end. If you already did the right, that's okay. Limit on the left end. Because you have to be able to describe your functions in limit notation. I've described this test as not that hard, but lots of little things. If you just like don't know limits, there goes a point. Okay, we all know that there's lim, duh, and then there's f of x, and then there's equals, and then there's down here, most of you are going to remember it's x and an arrow, which is approaches, and this is what the x approaches. On the left end, talk to the person next to you. What did the x approach? All right. X approaches negative infinity was correct. It's going, look, it's going way this way. And that's x approaching negative infinity. And then what's the y approaching? The y is out here. The y is approaching, well, it's going way up. Infinity. Negative infinity, infinity with two key things this time. That makes sense? Okay. I do want to talk about the right end just for a second because this limit is different. It doesn't have an infinity. Limit as x approaches, well, x does approach infinity because it goes way to the right. So that's infinity. And it equals, well, it doesn't keep going down forever. It has a lower limit. It stops at 0. It won't, it'll, you say equals 0, even though you know it just approaches 0. Gets close to 0. All right. So that's a good review of a lot of things. Now let's talk about the applications part. We just did that. And so we focused mostly on things that would like double, and then there would be a thing like this. And this has 15 yaks, and you get them to double every 5 years or something like that. Okay. But what if it's not a 2 in there? What if it's a 1/2 in there? Well, that's like half-life. Okay, can you write an equation like this? Well, let's see. I'm going to tell you a story. You make me an exponential equation for it. Okay? You have 1 single pound of gold. And you're an old hermit, and every time you want to go to the grocery store, you shave off a little bit of gold, like with your knife, because gold is very soft. And you cut off a little chunk of gold, and then you go into the gold dealer guy, and you give him some gold, and he gives you some cash, and then you go to buy groceries. Okay, so you had a pound of gold. That's worth a lot. Just for perspective, an ounce of gold is worth $2,000. Okay, so you can imagine a pound of gold worth a lot. All right, So the hermit has 1 pound of gold. He'll use up half of that every 18 months. So my question is, when will he have only a 16th of a pound of gold? This is one of those kind where you won't be able to do it because you won't have a calculator, but you have to know how to set it up. I'll say the story one more time. The old hermit has got a pound of gold. Shaves off a little bit such that he uses up about half of his gold every 18 months. Okay? My question is, when will he be down to only 1/16 of a pound of gold? I think some of those are easy to put in and some of them are harder to put in. Please write the equation and then compare it to the young scholar sitting next to you. Okay, at least you should have known that every one of these is always going to start like this. And then I told you things that filled in little parts of that until eventually almost everything was filled in. All right. So, please, there were some of you who haven't talked yet. Talk to the kid next to you. I'll pause for a second. Okay. So, some elements of the story. The hermit had 1 pound of gold. Right there, I'm going to put 1. Okay, next. He took off half of his gold. Okay, so that's the half-life thing. 1/2 right there. How often did he do it? Every 18 months. And this problem is in months then, not years. Okay. Then I said he was going to keep going until he had only 1/16 of his gold left, and that went here. How many of you figured out to put it there? Okay, awesome. Now, the reason that you can't solve this, and I say can't, but like you wouldn't want to, is because this would need logs. And if you've seen in the title of this test, it's really kind of misnamed. I think we should change the name to just exponentials because that's pretty much what we're testing you on. But it leads into logs because next unit, after this, we show you how to solve that using logs. Logs is not in this test. So what would you do? Well, you would leave this thing just like this. It would be good enough the way it is. You don't have to try to solve it. You just have to set it up. Okay? Now, I could ask you to simplify it, but again, you'd have to times things by 1. That doesn't really do much. And then from here, you cannot multiply or divide both sides by this because that has an exponent on it. So you really wouldn't be able to do anything to simplify this one. All right, so that's writing an equation. Here's one more. Here's 2 points. I'm going to tell you it's exponential growth. And you should know kind of that there's a curve through those 2 dots. But 0, 2 is a starting point. And 3, 8, it goes through. And so you know these kind of look like this, right? Can you write the equation for that? Remember that's that deal where you start with y equals ab to the x. Stick in what you know. The key really is to solve for b. Because once you know a, which you should already, and once you know b, you can write the equation. All right, dice of destiny. Who should I ask? If you get stuck, I will help you. But you can't just say you're stuck and get out of it, otherwise everybody just say that. So, row 4, person 4, Tully, that is you. Can you tell me how you start this thing?
It's like a equals 2.
Yes, that's 2. That's really critical. Okay, so y equals 2, b to the x. Why can't I just be done?
What?
Why can't I just be done?
Because 3 goes to the x's.
All right. I would say it this way, because we don't know what b is yet. We still need to solve for b. And so you said put x is 3. I agree. Now what?
And then 8 is y.
8 is y. And now what?
Divided by 2.
Divide by 2, so now I got 4 equals b to the third. How am I going to solve that? You got this, Tully.
B to the 1/3.
You are correct.
And then 4 needs to go to the 1/3.
Yes. Now, do you happen to have 4, the third root of 4 memorized?
No.
No. No, it's some decimal, but you don't know what it is. But we now know b is 4 to the 1/3. So can I do that in my equation? Sure I can. Everybody, if you haven't already, rewrite this, except now you know A, and now you know B, and you should be able to figure out how to elegantly put this in the right spot and get the final answer. Effie, the dice have chosen you.
Y equals
2 is the start value, because we knew that from here. And then what?
times 4 to the 1/3.
And now be careful here. Where do you put the x? Okay. There's only 2 choices. I mean, it goes in the exponent, right? If you put it here, I would have accepted it. 1/3 x. If you had put it in the denominator, I would not have accepted it. Do you get, we've never had one like that, ever? Okay, why? Well, if you times by x, if you're really timesing by x over 1, so the last way you could do is put the x on the top and say x over 3. And I think if you do it that way, you'll find it the most satisfying. Because if this is 1/3 x, it's x over 3. And see, look, it timeses by 4 every 3 days. Make sense to you? Okay. Then, without any further help, here's a new set of 2 points. Make sure you're good at this, even if it's decay. 0, 12 is my starting point. It goes all the way down to 6, 1 in exponential decay style. Can you tell me the equation for that? I'll pause and give that a shot. Okay, I'm hoping to start with a b to the x. Tell me how to keep going from there. Row 2, person 4. Nate, that's you. 12 is the start value. Yep. Okay, then what? We'll figure out b by doing what? 6 and 1 because of this and this. Okay, 1 equals 12. B to the 6th. Now what? Divide by 12. And now what? Yep. So how are you going to solve that? That's where a lot of kids are going to get stuck. Not times it by, but put it to the power of. Correct. And now I know B. It's this weird number that, again, I don't expect you to do in your head. The 6th root of a half? I don't know what that is. Question? What?
Isn't it 1/12?
Oh, it's 1/12. I dropped a 1 there. Sorry about that. That's 1/12. Sorry. That's 1/12. Okay. Even worse. 1/12 to the 1/6 power. I don't know what that is. But you should be able to then write your final equation because you now know A and B. So sum it all up for us. Greta this time.
Y equals 12 times 1/12 to the x over 6 power.
Nice. And that means over 6 days, weeks, years, whatever that is, our amount that we started with of 12 will be multiplied by 1/12. It will be 1/12 as big every 6 days or years or weeks or whatever. Okay, cool. I feel like you've got this. So there's a review worksheet, and I'm going to strongly recommend you do all of it. There's a key. I mean, hey, it's not that bad if there's a key and you get stuck. So I feel like this test is easier than last time, but then that gives you a chance to like pull off a nice A. Why would you want to build up a buffer? Because the final is coming. And this is going to be an easy one. I think your next one's going to be a medium one. And then the final, and that's hard. Almost everybody does worse than average on their final. So you want to have built up a little bit of cushion so that if you do a little worse on the final, you get a B minus where you're used to getting A minuses, that it's not going to torch your grade. Okay? So, do study. Pull off the A on this test. Be really smart. And that's all I got for you for today.